Okay, we left off on 2, right? Ready? We had done 2C, we were ready for 2D.
Yeah.
Okay, so what have we done so far? We had a table, we knew it was differentiable, so that's continuous. We had found the particle moving left or right. We had talked about, is there any time when the particle's at rest? We had to show that it moves from negative to positive. And then we had just found v prime of 8 and talked about the fact we know the velocity is increasing at that point. Okay, D is what we were ready for. Average acceleration for the particle, or of the particle, for the interval 10 to 12 seconds. Explain what this number means in terms of the particle's velocity on the interval.
It's just average rate of change.
Okay, so yeah, when they say average acceleration, we are thinking average rate of change, which is going to be using our velocity data, right? They specifically said on the interval from 10 to 12. Do they give us that data up above? Dang it. Oh my gosh. So they do give us the data from 10 to 12, so we can use that. So we can set it up as v of 12 minus v of 10 over 12 minus 10. Grabbing the numbers from above. 3 minus 5 over 12 minus 10. Negative 2 over 2, which is negative 1 what?
8 per second squared.
Okay. And then it asks us to explain what this number means in terms of the particle's velocity on the interval.
It is decreasing at a rate of negative 1 per second squared.
Okay. Only thing is you wouldn't have to say, if you say decreasing at a rate, you could just say at a rate of 1, because by saying decreasing, you've already said negative. You've already indicated the negative.
I'm looking. That was the negative.
So velocity is decreasing at a rate of 1 foot. What if I say per second? Per second. Could I do that?
Yeah, but why?
I agree, but why? But I throw that out there just as a, are you aware that feet per second is the same thing as saying feet per second squared? Okay. It's more than anything why I throw that out there. Making sure everyone is comfortable with that. Okay, E. Let A of t equals v prime of t. That's common knowledge. Is there a time t equals c guaranteed such the acceleration of c is equal to 0 in the interval of 0 to 15? Justify your answer.
I'd say no.
Yeah, not with the information provided.
Because the velocity is always changing.
Well, what are we looking for? We're looking for, when would acceleration have to equal 0?
When the velocity is constant.
Don't think in terms of that. When do we talk about when does velocity equal 0?
X-axis.
When it crosses
you're
through.
Asking when the derivative of velocity equals 0.
Mm-hmm. Okay, so if we're asking when does acceleration equal 0, then we can talk about when does velocity equal 0.
Between the points,
The velocity can be 0, the acceleration can still.
between the points of 10 and 12, or between the points of 7 and 12. has to stop at some point in order for it to decrease.
Okay.
Right?
What did we find on part C? The velocity over the interval from 7 to 10, or excuse me, the v prime of 8, so acceleration, okay, or average acceleration was positive over the interval from 7 to 10. What did we find over the interval from 10 to 12? It was negative. Okay. And so is there a time guaranteed that your acceleration is 0 in the interval from 0 to 15? Somewhere between on the interval from 7 to 12. We don't know exactly where.
And from 12 to 15.
And I wasn't even going there. But I was just using based on the information we know. Okay? And that is because of what we'd already found out. Now, do keep in mind, we were told differentiable, thus we were told continuous. In order to imply this, it has to be continuous, right? Otherwise, everything we just said doesn't matter. Okay, it doesn't work. So, couple of things I have on my notes. Because v of t is differentiable on 0 to 15, then a of t is continuous. Okay, so we have to state that acceleration would be continuous here. If you gather your information from above, v10 minus v7 over 10 minus 7, that was the one that equals positive 2/3, which is greater than 0. The other one we had was that v12 minus v of 10 over 12 minus 10 is equal to negative 1, and that is less than 0. Okay, so there's your proof that at some time acceleration had to be 0 in between, within those two intervals. Okay, so I'm going to say, thus, a of t equals 0 on the interval 7 less than or equal to t less than or equal to 12, since v of t changed from positive to negative. Okay, we just don't know where. Okay, now we've got a graphical stim to look at. I cannot recommend enough, always notice what is this a graph of, because they will try and trick you in so many ways. It will always be labeled and it will always say, or at least one or the other. So the graph of the right is y equals v of t, the velocity of an object moving on a line over the time intervals 0 to 10. Assume that the positive direction is to the right. So, on what interval of time is the object moving to the right?
4 to 10.
Because when velocity is positive, right? When v of t is greater than 0, so v of t is greater than 0 on the interval 4 less than t less than 10. Okay. When is the object speeding up?
Between 4 and 6,
And why is that?
because it's getting farther away from the x-axis.
Okay.
Well, so it'd just be 4 and 6 because both velocity and acceleration are positive.
Okay.
No other place is
Yeah.
They match up like that.
So, and here's the deal. Remember, if an object is speeding up, you need velocity and acceleration to have the same sign, right? Now, that same sign could be both positive or it could be both negative, but we don't have that happening here. So, our answer is indeed on the interval from 4 to 6. And I'm just going to say, since velocity is positive, and now, the way I have mine written is v prime of t is greater than 0. Okay? So that's just saying that velocity and the slope of velocity are positive. How fast is the object moving at time t equal 3, and in what direction?
Oh, it's -5 to the left. We don't have units.
Yeah.
So it's moving what direction?
But
How fast is it moving?
5.
So even though, yes, at 3 the point is -5, but remember how fast is asking speed. And so speed is the absolute value of velocity, right? And the absolute value of v at 3 is 5. Okay, so, and it is moving in a negative direction. So you could say moving, what did they say? Assume that positive is right. So yeah, moving left, since v of 3 is less than 0. Okay.
So we don't have to put units.
They didn't give us units, did they? So no. Okay. D. What is the average velocity over the interval from 0 to 4 and 4 to 10? Show the computations that lead to your answer. What are we going to talk about with average velocity?
Rate of change.
Okay. How are we going to find that?
V of 4 minus V of 0 over 4 minus 0.
We have to be careful here, because we have to, and this is where I'm trying to make sure I have it. I think on 0 to 4 it would work, but I think we'd run into a problem on 4 to 10. Okay, because average velocity is not going to just be about my distance from point A to point B. My displacement, in other words. It's not going to be just about my displacement. It's going to be about the total distance traveled. Okay, so you have to look at total distance. We are, I guess the way I have it written in my notes is I have it as thinking about change in S over change in T. The change, well,
Displacement over elapsed time.
yes. But, hold on. This isn't making sense. My notes aren't making sense. Hold on. Oh,
Well, to do that, we have to find the distances.
exactly.
So it's going to be.
So, yeah. Here's the deal.
So it's gonna be 6/4.
Hold on. On 0 to 4, on the interval 0 to 4, how are we going to find the distance traveled?
By the area under
The area under it, yes? So on 0 to 4, what do we have here?
6.
Like, my brain blocks it up. It's not 6, though.
20 plus 10.
This is a 20. Were you forgetting the counting by fives?
Yeah.
Okay, that's what I was trying to figure out where you were doing. 20 and 10. Now, technically, these are under the x-axis, so they represent negative 20 and negative 10, yes. Okay, so, whoops. In that point, you're looking at negative 20, whoops, minus 10, which is indeed the negative 30. And so if we look at,
Just know it's negative 30.
huh?
You don't have to do that. Just know it's negative 30.
Well, right. You know, it's, I mean, I was just, because I had broken it into 2 points.
It'd be negative 30/4.
Right, yes. So here, our average velocity, negative 30/4, which is,
Negative 7.5.
I could go with that. Okay, so that's over the interval from 0 to 4. Repeat the process on 4 to 10.
Yeah. 60.
Okay? Yeah. My brain did 15, 30, and 15. However you did that.
30 plus 30.
That works, Again, it's however your brain gets there. Some people might just do a trapezoid. Whoops. Regardless, you're looking at 60. And so my average velocity in this case is the 60 divided by 4, which is 15.
6.
Okay, wait. Try this again. Yeah. 4 to 10 was 6, and 60 divided by 6 is 10. Better? I'm glad you guys have mathed, right? Save my math.
As total distance, does it want everywhere it's gone or the displacement?
Okay. Now what'd you ask? Total distance.
The distance doesn't want everywhere it's traveled or the displacement.
No, total distance is total distance.
So it would be 90. Which is 90. I don't really
Because, right, and I do actually have 90 units on this one. But what did we just do? We just looked at 0 to 4, yes? And from 0 to 4, its displacement was negative 30. But the total distance is going to be the absolute value of that. So you're looking at the absolute value of negative 30. Plus, then, from 4 to 10, we just had the 60. And so, again, yep, 30 plus 60 is 90. I just said earlier I don't have units, but on this one I did write 90 units for whatever reason. Okay? Are we okay with that? When is the object slowing down?
2 to 4.
8 to 10.
Yep.
And that is because velocity and acceleration have?
Not great.
Now, if I have to justify in this one, on 2 to 4, it's because my velocity is less than 0 and my acceleration is greater than 0. On 8 to 10, it's because my velocity is greater than 0 and my acceleration is less than 0. Okay? When is the velocity increasing?
2 to 6.
Why?
Because the acceleration is positive.
Okay, so acceleration is positive, and so that is on 2 to 6. My explanation is that acceleration is positive. Acceleration is greater than 0. On what interval does the object move at a constant speed?
0 to 2.
Because
Acceleration is 0.
acceleration is 0. So 0 to 2, 6 to 8.
Nice lower P.
Grab your calculators, it looks like.
Page 2, what's that? Grab mine too, please.
I don't know if we'll get through all this then. I don't know, maybe. Okay. An object moves along the x-axis for time 0 to 6. The velocity of the object at time t is given by v of t in that lovely fun formula. Thus, it is a calculator active problem. And you see all that jazz. For t equals 4, is the object speeding up or slowing down, and justify?
Find the velocity and the acceleration.
So we need to find v of 4 and a of 4. Am I doing any of this by hand?
Nope.
No way, Jose. Now, what do you remember how to do? Now, would it be advantageous, I don't know, to type this formula into y1?
Good.
You could. I don't know if it's necessary or not. It's up to you.
How you natural on you? Never mind.
There's a button. So I'm going to type mine into y1. You don't have to. I'm not sure how much it might help us some, actually. Okay. Now, since I typed mine into y1, I'm going to go back to my screen and do alpha F4 is where I can find y1 and just say y1 of 4. And that finds my velocity. I'm going to write down my velocity with at least 3 decimal places because that's what calc wants. Now, it looks like I just truncated mine, so 4.496. You can truncate it around.
Oh, this is disgusting.
Now, you're not doing the derivative by hand, are you? Are you using your calculator?
No, because we've never used it for derivatives.
We have. I showed it to you. We showed it to you. You used it.
Sorry,
briefly.
we never use them on the test, so I don't get
Okay.
it.
So you do have, if you have an equation and you know what number you're trying to evaluate, you can find the derivative. Remember, officially it's in the math menu, number 8 in deriv. It's also in your alpha F2 menu, number 3 in deriv. And what I can do, you can put the in deriv there, so it's that dx setup. You fill in x here. You either type your equation, or this is why I put mine in y1, and we're evaluating it at 4.
I put the 4 into that.
No, your equation is just going to be in terms of x's and you put the 4 at the end. If you don't put the x in, otherwise the derivative of a constant is 0. Is this the unit? Is it unit 4 or unit 5 where you actually get to use a calculator on a test? I don't remember. Okay. I wrote down the answer without asking. But I know you guys will know the answer once you have all the data in front of you.
Oh, yeah.
Are we okay with that? Can we get the calculators to cooperate?
Yep.
Okay. At what time does the particle change directions on the interval from 0 to 6?
So what point does velocity equal 0?
Keep in mind we're using the calculator for everything.
Between 0 and 1.
I'm going to need more specific, but how do you know between 0 and 1? What are you looking at?
The x-intercept. Right? I typed it in.
Yeah. So,
0 weight.
second calc. What's another name for an intercept? You don't want an intercept. You want to find the 0. We used it all the time last year in pre-calc. It's just been a hot minute since you've used it. There you go.
Okay, let's see if I can
Is there a second one?
I think that's
trace.
And count again, it's around 5.
0. There we go.
Yeah.
What do we get?
The first one, 0.391.
First? Oh, there's 2.
So velocity equals 0 at t equals 0.391. And what's it doing there? It changes from, if you look at your graph, we know at 0.391, velocity changes from negative to positive.
You can just listen to it and say because velocity is 0.
No, because velocity means 0 does not, we talked about this yesterday, the particle does not guarantee to change directions. Velocity equals 0 means the particle stops. Okay? It could continue in the same direction. Velocity also equals 0. Did you guys find the next one yet?
5.007.
Mm-hmm. Okay, I have 0.007 written on mine, so yeah. And this is because velocity changes from positive to negative. Now, could you list the 2 times and say because velocity changes from positive to negative or negative to positive? You could possibly do that. Okay? Okay. Example 5. Are we ready? Particle moves along the x-axis, so at any time t greater than 0, its velocity is given in meters per second by the function v of t as provided. What is the acceleration of the particle at t equals 4, and what does this tell you about the direction of the particle? So what is the acceleration of the particle at t equals 4? What do we need to do here?
I already have the acceleration. T equals 4. Oh, this is a new problem.
Totally new problem. What do we know about acceleration?
Derivative.
It is the derivative of velocity. Now, do you have to find the derivative by hand? No. Now, I will say in this one, last one, it was beneficial to type it into Y1, wasn't it? Because we used it a couple of times. This time, the only question on this one is this question. So you could get away with just doing your inderiv and typing the equation directly into there if you wanted. Or you could put it into like Y1.
Yep.
Get the same answer as me? Now, for whatever reason, I wrote mine down as negative 1.89009. Minimum 3 decimal places, boys. Now, what does this tell you about the direction of the particle?
Velocity of the particle is decreasing at a rate of 1.89 meters per second squared.
Okay. Okay, so you talked about the velocity is decreasing. But what about the direction?
No, because we haven't found the velocity.
Well, but the acceleration is negative. What would negative acceleration be doing?
It's still a positive velocity. It's like slowing down the car.
Well, but we're asking about direction here. We're not asking about speeding up or slowing down.
You can't know that with the acceleration.
If the acceleration is negative, that means the particle is being pushed left, is what we know.
Doesn't mean it stopped moving right, though. It's like putting brakes on a car. The acceleration is to the left, but the velocity is still to the right.
I still want to argue it's being pushed to the left because of the negative acceleration.
I'm pretty confident on this one.
I don't know. I'd have to look into it then, because I'm going with what I have in my notes.
It's like the graph. You can have a positive velocity and still have a negative slope. That's the same concept. And we said velocity was still.
I hear what you're saying.
I bet you asked Mr. Kevin, that's what he said. Because you can have negative acceleration.
Yeah, I get it. So I have to look into it to know for sure then. But my basic belief was that, or understanding, particles being pushed left, and it's being pushed left at this rate of negative 1.89 meters per second squared. And I guess, okay, it's being pushed left. Does that, the way that's stated, does that mean the particle has to be going left? It's being pushed left.
Yeah,
because
sure,
the velocity is overpowering to the right.
Sure, it's being pushed left. Well, but that's not going to make sense because acceleration means it's going to overpower the velocity. I mean, because eventually
it's still pushing against it. I don't know.
But the velocity is going to slow down with a negative acceleration.
Yeah. I don't know. That's the best I got for right now. Short of looking into it more. Okay. Let's see. I don't know. 6 versus 7.
Oh.
Okay. An object moves along a line so that time t between 0 and pi, its position is given by s of t. What is the velocity of the object when its acceleration is 0, and describe the behavior of the object? Why do I have so much information written out when I should have just done this on the calculator?
You find the derivative of it, copy it into the Y menu.
Huh?
So we find the derivative of it, copy it into the Y menu, find the 0, and then plug that back in.
Unless I copied it in wrong, which could be very possible.
-3, so
It is possible.
Okay.
I had an extra bracket somewhere. I'll think of
+1.
Oh, I see what you said. Okay.
So what do I, if I just want the derivative of it without an x value, how do I do that? Plus,
Thank you.
You could put equals. Are you looking at the graph?
no, not yet, because I want to get the acceleration so I can get the acceleration graph.
But you can't. That's the thing. A calculator won't give you the actual derivative.
It's dumb.
I know.
$100 for a reason.
Now,
Can't do derivatives?
here's what you can do though. Okay, they give us position. If we find, no, can we do that? I have a bunch of stuff written out by hand here, and I don't feel like I should, but I'm wondering if I do the derivative here and then just put equals x, you can do that. I'm questioning if it's going to work though. Oh, lovely. So with this, what I just graphed is the derivative of position. So I just graphed velocity. That is velocity we're looking at here. When is the acceleration going to be 0? Acceleration is going to be 0. See, it didn't work though. Okay, I'm going to be
Because
running
once
it.
out the velocity time graph,
Mm-hmm.
there's no slopes, or slopes is 0, sides of it is maxes. That's a lot.
Well, we're only on the interval from 0 to pi though.
Oh.
Oh, okay, 0 to pi.
Yeah, so you just get it right there at the bottom.
Yeah, so if you find that min,
Yeah. That'd be useful.
and there we go.
Yep.
Okay, so acceleration is 0 at 1.6. Okay, now, here's a good lesson. There's that value. I just found that min value of 1.6 whatever, right? Because that's the last thing I found in my calculator. That x value is what is currently stored in place of x. Does that make sense?
Yeah.
So now, they're asking for the velocity of that object. I put velocity into y1, didn't I? So let me try. If I do y1, evaluated at,
1.6.
but I'm just going to use x because that's the last thing that it found. And that gives me the right answer. And if you put in 1.6, it should give you a similar answer, but don't ever just use 1.6. Always use at least 3. Okay? Now, to write all that down, oof.
You don't need to do all that. You just write a of t equals 0 and t equals 1.6, and you write v of 1.6 is that, and then you say it means it's at a constant speed, or constant force.
Then you make your own notes about how we did this because we're going to look back at this and say, what did we do?
Are we using calculator on this test?
I don't remember. It's either unit 4 or 5 that they come back at us. And I start letting you use calculators again, but I don't remember. Okay. Now, the question was, then describe the behavior of the object.
Is it a constant velocity?
Well, acceleration,
It's constantly moving left.
it's going to be moving left, yeah.
Constant.
Okay, well, we got all but one done. And you can always look at it in the, the notes that are online. Homework, do 4.2 for Monday.